Hello, my name is Dmitry. Welcome to the DPLABS channel. Today, we will tell you about the new version of the Apocalypse clock, improved and more refined. Why is this clock called the Apocalypse clock? Because they're electronic. Because they're constructed on vintage Nixie tubes, gas discharge lamps, and stepper switches. And in the event of an apocalypse, even if all electronics are destroyed, the stepper switches will remain in their current position. And future archaeologists, when they dig them up, will be able to understand how the apocalypse happened. The operating principle of these clocks is based on switching the contacts of gas discharge lamps using stepper switches. Similar stepper switches are used in crossbar step-by-step telephone exchanges, but those are much larger. What is the operating principle of a stepper switch based on? It has a ratchet mechanism and an electromagnet, and it connects one contact. The main one with these lamellae, that is by applying a short pulse, it jumps to the next contact. So, by having a clock pulse, 1 per minute, we can switch the lamps. How does this version differ from the previous one? The difference is that in the first version, a clock pulse generator based on the ESP32 was used, and it was hidden inside the power supply. So let's say these are secondary clocks. They need a sync pulse. Here, we went further. We took a frequency reference from a radio relay based on rubidium atomic clocks. It outputs 10 megahertz with an error of 1 second in 10 billion years. We bought it on eBay, seems to be working, cost $100. We divided its frequency down to a kilohertz, I think. Then using counting hydrogen decatron tubes, we divide the frequency by 10, switch the magnetron, divide by 10 again, switch, divide by 10 once more, and then divide by 6, and we get a 1-minute pulse. Why was all this done? Well, let's put it this way. This clock is a piece of engineering art in the techno-porn genre because we want to. This clock is very accurate. It looks beautiful. The sound is absolutely amazing. I really like it. These decatrons aren't just for show, like people often use them. They actually work as dividers here. The tubes actually look like the Soviet NN18T, but they're much larger overall. The prototype for this tube was a Czech tube from the 1960s to 70s. And one person from the Czech Republic actually revived them, restarted their production. There will be a link to his website in the description. He makes very beautiful clocks. Though, the price is quite high, about 150 euros each. But they're worth it, they're just beautiful. So what the hell was I saying next? The time on this clock is set using 2 buttons. Hours and minutes. With this button, we simply adjust the minutes, and with this one, the hours. You might ask, why are there so many stepper switches? 2 of them are used for the anti-poisoning mode, because if the same digits stay lit on the tubes for a long time, poisoning will occur of the cathode. And to help prevent that, you need to cycle through all of the digits. After about 10 minutes, the system will cycle through all of the digits in a continuous loop. That's enough. The idea for this clock is mine, but my Belarusian friends assembled it. They put in a lot of effort. It was very difficult to assemble and especially to calibrate them. All the wiring here is done with wires, everything is neatly arranged, everything is beautifully connected with connectors, for which they deserve special thanks. This clock consists of 2 modules. The lamp switching module, we looked at it, I showed it to you. Let's open it up and see what's inside this module. There's real beauty in here. What do we see inside? A 10 megahertz frequency standard generator based on rubidium atomic clocks. Then there are electronic dividers, and after that dividers using counting decatron tubes. Here are 4 of them, which are switched through an ignitron.
Decatrons are used here. These ones, for example, OG3, this one here is from 1978, for instance. This is a hydrogen counting decatron. You can still buy them on Avito. They're not expensive.
These kinds of ignitrons are used here. Small and quite nice. From as far back as 1986. So what else do we have here? There's all sorts of wiring and a relay here. There are also switching power supplies. At first we used transformer-based ones, but when the mains voltage fluctuates, it's hard to work with them. So, well, we decided to do it this way. So, ladies and gentlemen, I sincerely hope you liked my Apocalypse clock. If you're interested, you can find the schematic for this clock in the video description. Also, if anyone has questions about the circuitry or how the clock works, feel free to ask them in the comments. Subscribe to the channel and leave a like. All the best, goodbye!